we're going to start talking about section 2.7, which is the section on inverses. Now, basically, inverses are two functions that cancel each other out. Okay? Inverses are two functions that cancel each other out. So, for example, one function might be x cubed. So x cubed. And another function might be the cube root of x, right? So x cubed and cube root of x would kind of cancel each other out. Or say 3x. So think about what kind of a function would cancel out 3 times x. What kind of function would cancel out 3 times x? How about x over 3? I can either multiply by 3 or I can divide by 3. If I multiply something by 3 and then divide it by 3, I'm essentially undoing it. I'm canceling it out. F of x equals x plus 5. So if I add 5 to something, how do I get rid of the fact that I added 5 to something? I would subtract 5, right? I always think about myself. This is me, my hair and my bangs. I am like a function, and then my toddler, this is him with the spiky hair, he's like an inverse function, because like I clean the house and I make everything like tidy and stuff, and then he knocks everything down. So like parents are like functions and children are like inverse functions. They like go out of their way to like mess up your house. And that's kind of like what functions are. Okay, so let's do an example. So if I have, let's look at this f of x being x cubed and g of x being cubed root of x. So we have this one. Now, say I let, so I'm going to say let x equal 8. So the idea is, if I take 8, cube it, if I take 8 and cube it, I get 8 cubed is 8 times 8 times 8, which is like 64 times 8, which is, okay, I can multiply, I promise. It's like 64 times 8, which is 51. There we go, 512. So if I cube it, I get 512. Now, if I take the cube root of 512, what am I going to get? Well, hopefully you recognize, because I just did it, if I take the cube root of 512, I'm going to get 8. Right? So that's like saying, well, if I took f of 8, I get 512. And then if I take g of 512, I get 8. Right? If I take the cube root of 512, I get 8. So that's g of 512 to get 8. Similarly, if I take, I can spell, I'll get there. I lost my f. If I take 8 and take the cube root of it, I get what? What's the cube root of 8? 2, right? And then if I take 2 and cube it, I get 2 cubed, which is what? 8. Right, so this is another way to say it. I can say if I say g of 8 is going to be equal to 2, and then f of 2 is equal to 8. So you see kind of what we did? Okay, maybe. I'm going to try writing it this way. In fact, give myself a little bit of space here. Put this down 2 lines. So now that you're looking at both of these, see what's happening here? Is really I'm taking, the idea is if I take f of, let me try this again. Let me work from the inside out. If I have g of 512, I get 8, right? Right? Now what's 512? So where did I get this 512 from? Well, I got the 512 from doing f of 8, right? So that means g of f of 8 is 8. Is this making any sense? Yes? No? Maybe? All right, let's try this one down here and see if that works. So I said f of 2 was 8. All right, well, where did I get the 2? Where did I get this 2? I got the 2 from doing g of 8. So 2 is equal to g of 8. So that means f of g of 8 is 8. All right? So that's what this is why it's kind of weird. These are inverse functions. So the idea behind an inverse function is, inverse functions. The idea behind an inverse function is that if I take f of g of x, I'll get x. Or if I take g of f of x, then I'll get x too. So basically what that means is these two functions undo each other. And this might take a little bit for this to sink in, and that's okay. So just kind of look at this and see what we did here. We took the 8, we cubed it to get 512. We cubed root of 512 to get 8. So basically, we took the result of 1, plugged it into the next function, and got the answer. Then down here, we took the g of 8 to get 2. Then we plugged it into f. So we got f of 2, and we got our original answer back again, which is 8. All right? Maybe a little bit? Kind of? All right. Well, that's pretty much what we're going to be doing today, is finding inverse functions, finding functions that undo each other, because that's pretty important. You know, if you do something to something, it'd be really, really nice if you could undo it later, and that's the whole idea behind inverse functions. So we have a special notation for inverse functions. We actually don't call them f of x and g of x. What we actually would do, so for example, here we had these two. We had these two here. So really what we would do is call them, instead of having f of x and then g of x, what we would really do is we would say, well, f of x is x cubed, and then f inverse of x is the cubed root of x. So the way we say this is f inverse of x is the cubed root of x. So this is really the format that we use. So we can say if f of g of x is x and g of f of x is x, it's like kind of like Dr. Seuss, Fox and Socks and Box and Clocks. Then those functions are inverses of each other. So we're going to spend a lot of time talking about inverse functions and figuring out how to manipulate them.